Hi, AIX Portal, an independent community of IT professionals, is online. This is AIXology, the AIX video tutorial series. My name is Dmitry Mironov. I'm a power systems expert. I've been working with AIX operating system for a long time. I like this system. I'm sure that after my story about its features, you will like it too. Disclaimer. Everything that I'm telling is based on my personal experience and publicly available documentation. I do not guarantee the absence of any mistakes in my story, and I am not responsible for anything. The topic of today's lesson is Logical Volume Manager. We will look at its components, learn about its main features, and see how to work with it. Let's go! How is the data storage organized in Unix? At the lowest level are bits, ones and zeros. They are combined into bytes. Bytes are in files. The files are located in directories. The directory structure forms the file system. The file system is located on logical disk space. Logical disk is located on a physical disk. This is probably the same in almost all operating systems. But in some, including AIX, the logical volume manager is located between the logical and physical disk space. LVM. What is it? It sits between the physical disk drivers and the file system layer. In fact, it's also a driver, LVDD. It's a component of the AIX kernel. It maps high-level disk I/O system calls to low-level ones. What features does LVM provide? Adding, reorganizing, and removing physical disks. Logical volume management, including growth and reduction. Software rate 1, mirroring. Software rate 0, striping. Snapshots, and much more. Almost all of this is done on the fly, without unmounting file systems, without interrupting data access. Do you remember what a spined hard disk drive looks like? Okay, let's look at the long way from the physical disk to the file. First of all, disk is a device. You have to physically connect it to the server. Probably you create a RAID array or LUN logical unit number at the external storage subsystem first. Then you should have appropriate device drivers. You deal with multipathing and so on. It's not a subject of today's lesson. I will explain how to work with devices at the AIXology part 3. I promise you, this part is already finished. So, don't forget to subscribe to the AIX Portal channel. Anyway, at least we have a logical device called HDiskX in the AIX. Look at the lsdev command output. And surely we have corresponding special files in the dev directory. From the LVM point of view, there are no disks, but physical volumes. It's the LVM terminology. The name is the same, HDiskX. It corresponds to the related HDiskX device, one by one. But now it's not a device. It's an LVM component with different attributes than HDiskX device. You don't have to create a physical volume. All disks are physical volumes in AIX. If not, then such type of disk is not supported by AIX. You have to install appropriate device drivers. Remember, physical volume, not def HDisk X, but just HDisk X. Physical volumes are organized into volume groups. A physical volume can be in one and only one volume group. That is, a physical volume cannot be in two volume groups at the same time. If you see this, then this is some kind of malfunction. It's a bug and needs to be fixed. Until a physical volume is included in a volume group, it cannot be managed at the LVM level. First, it needs to be included in the volume group. The volume group that is automatically created during the AIX installation is called the Lsvg. The operating system is located on it on Lsvg. The name is reserved and cannot be changed. Of course, you can technically try, but the result will be unpredictable. Additional volume groups that you create yourself, you name it your decision. Usually VG is added to the group name for clarity. It's just for clarity. For example, DataVG, AppsVG, WebVG, and so on. If you don't specify a name when creating a group, then the name will be VG00, VG01, and so on. It will be automatically assigned. When a volume group is created, all physical volumes included in it are divided into physical partitions. This is a logical division. No long-time formatting is done. It's absolutely not the disk formatting. It's different. The size of the physical partition is the same within the volume group. It's specified when the group is created. If you have not specified it, the operating system will select it on its own. Practically, the size of the partition should be hard disk size divided by approximate 1000. It's how the operating system decides the size of the physical partition. Then it's almost impossible to change the size of the physical partition on volume group, only through backup and restore. Physical partition is the minimal allocatable unit in the logical volume manager. You cannot create a logical storage with less than one partition. So it should not be too large. But on the other hand, if the disk is quite large, then a lot of small partitions create unnecessary addressing. Nowadays, I often use 1 GB partition size, but it's not my recommendation at all. Just my practice. Okay, here we see that on Lsvg, the size of the physical partition is 256 megabytes, and on DataVG, 512 megabytes. Physical partitions are numbered 1, 2, 3, 4, and so on within the physical volume. Each physical volume has its own numbering, starting from 1. If we add another physical volume to an existing volume group, it will also be divided into physical partitions with the same size. logical volumes. This is a logical disk space. A logical volume consists of logical partitions, which are numbered 1, 2, 3, and so on within each logical volume. Each logical partition is mapped to one physical partition. A logical volume can be located within one and only one volume group. I emphasize again, even if in several volume groups we have the same physical partition size, a logical volume can only be placed within one volume group. Another volume group is it's a different planet. As I said, each logical partition is mapped to one physical partition. So, what is the size of a logical partition? That's right, it's equal to the size of the physical partition. Please note that a logical volume can be located on several physical volumes. It may not be located sequentially. In this example, I especially made a chaotic placement to show you the capabilities of LVM. The name of the logical volume. The same rules as the volume group names. If you don't assign a specific name, a volume will be named LV01 and so on. Usually we add LV at the end and for example DB2LV, APP data LV and so on. It's the key to understanding the LVM. Volume groups, physical volumes, physical partitions, logical partitions. Set this video to the pause. Look at this diagram again. If everything is clear, let's move on. If something is not clear, go back to the previous slides again. Or keep watching, you will figure it out in the course of my further story. Ready? Go. Again, logical volumes. Only one component can be placed on the logical volume. What are these components? One file system lock. Yes, I know that to GFS2 there can be an inline journal that's located on the same logical volume. But this is a GFS2 feature, not an LVM feature. It's still just the single GFS2 with included GFS lock. One structure, not two structures. Single paging space, it's also known as swap. Single boot logical volume. It's used during the system startup procedure. Single dump device. Or it may be a raw logical volume from the LVM point of view. Your application, which is not a part of the operating system, is responsible for storing data on this logical volume. In such case, LVM will still work as a driver, providing you logical storage and most of benefits. About the file system types. GFS is an old one. GFS2 is MonU, but it came a long time ago too. I think now nobody uses old GFS because GFS2 is much better. However, The default logical volume type in AIX 7.2 is still GFS. Why? For a backward compatibility. We will see AIX 7.3 very soon, but I can bet that it will be still GFS as a default logical volume type. That's why I like AIX backward compatibility. I don't have to worry that the default system behavior may change. File systems. Here we see the most of the standard file systems that are automatically created when installing the AIX operating system. These logical volume names and file system mount points are predefined and do not have to be changed. HD4 root file system, HD2 USR, HD9 var, and so on. So we went from a disk device to a file. Enough theory. Let's move on to examples. The command line, my favorite part of the show. Lsvg, list volume groups. Lsvg -O, list only active volume groups. If the volume group is not active, you can't do anything with it. You cannot mount a file system from it. You cannot activate a paging space on it. You cannot create new logical volume on it. It's closed, not active. Usually, volume groups are automatically activated, named vary on, during the system startup. Some exceptions are shared volume groups in the PowerHA cluster. Lsvg group name lists exactly these volume groups attributes. All attributes are important. I highlighted just the basic ones. Total PPs, free PPs, used PPs. Yes, I will use abbreviations next. LP, PP, VG, PV. I have to remember it. It's basic. Okay, total, free, and used. Physical partitions. We see how many physical partitions do we have in this volume group and how much space is free. Surely total should be a sum of free and used. Total PVs equal to active PVs, physical volumes. It's good. All physical volumes are active. Stale physical volumes is 0, as well as stale physical partitions. Stale is out of sync. It should be 0. Auto on. This volume group is activated automatically during the system boot. By the way, it's the root volume group. Surely it's automatically activated. Lsvg -P, physical volume group name. P means physical. We see more detailed information about which physical volumes are included in the volume group, their size in partitions, and how much free space is on each specific volume. This is important. For example, if we want to do LVM mirroring. Yes, I not explain the meaning of all fields. Otherwise, my lesson would have lasted for several days. I'm explaining the basic concepts here. In next AIXology lessons, we will return to the LVM more than once. Now let's go forward. Lsvg -L volume group name. L means logical. We can see which logical volumes are located on this volume group. We see their type and mount point, if it's a file system, size in logical and physical partitions. Did I tell you that one logical partition corresponds to one physical partition? I haven't told you everything. Pay attention to HD4, force from the top. You can see that it consists of 6 LP and 12 PP. Count as 1, 2, 2. What is it? LVM mirror. We will come back to it later in this tutorial. Now look at HD9 var. The PP amount is equal to LP, but PV number is 2. 2 physical volumes. This volume, this logical volume, is not mirrored. It just sits on 2 physical volumes. And let's look at test LV at the bottom of the list. It's closed. Probably they haven't created and mounted a file system on it yet. HD5, first on the list, is also closed. It's normal. It's the boot logical volume. It's used only during the system startup. Once again, most of these logical volume names, except test LV, are default ones. Quiz time. Let's hide and forget the first command at the screen, Lsvg-P, and look only at the Lsvg-L. Ready? Now answer the question. How many physical volumes are in this volume group? A lot of times I've got an answer, 2, because we see 2 PVs for HD4 and HD9 var. Wrong. On this output, we see that HD4 resides on 2 logical volumes. Yes. HD2 on 1 logical volume. Okay. But they don't have to be the same logical volumes. So the correct answer, there are at least 2 physical volumes in this group. It's not a correct command to get such information. Use Lsvg or Lsvg-P to find out how many physical volumes are in this volume group. Lspv. Let's look at the physical volumes attributes. Command without parameters shows a list of physical volumes and which volume group they belong to. The long number is the volume ID. It's physically written to the initial sectors of the disk. The operating system uses it for identification. If it's actually a physical disk manufactured by IBM for power system, then the PV ID is written to disk at the factory. If not, for example, if this is a LUN logical unit number from external storage subsystem, then there is no any default PV ID. For example, HDisk3. ID will be automatically generated when the disk is included in the volume group. Lspv volume name. This command will only work if this physical volume is included in the volume group and the volume group is active. If not, it will show an error. What do we see? What VG is this disk in? This physical volume. Physical partition size. How many physical partitions are there on this physical volume? How many are occupied and free? PV state, active, perfect. Stale, 0, it's good. It means there are no not synced partitions. Allocatable, yes, it's good. New partitions may be allocated from this volume. By the way, you may voluntarily set this attribute to no to exclude this physical volume from allocation to keep it as a reserve. We will describe these attributes in more details in next AIXology lessons. Lspv minus L volume name shows what logical volumes there are on this physical volume. Looks similar to Lsvg minus L command, but here we see exactly what is on this particular physical volume. For example, HD5. We see that there are two logical and two physical partitions of this logical volume located on HDisk 0. It should be already understandable to you because I've described that one logical partition maps to one physical partition. But let's look at the data LV. We see 5 logical partitions and 10 physical partitions. What does it mean? If it's not an error, then it means LVM mirroring, software rate 1. In such case, one logical partition maps to 2 or even 3 physical partitions to make a mirrored copy. Yes, we created both mirrors on the same physical volume. It's not good from the data safety and performance point of view. I did it just to show the possibilities. By the way, in some situations it may have a sense. I'll describe it again in next AIXology lessons. Question. What is the size of the USR file system? The last in this listing. How do you say? 247 partitions? Maybe. But it may be larger. The command shows only how many logical partitions of this logical volume resides at exactly this physical volume. Not the whole size of the logical volume, just what resides on this physical volume. How to look at the logical volume attributes? Lsvg, logical volume name. We see the corresponding volume group name. This volume is opened. For file systems, it happened when the file system is mounted. We see the size in logical and physical partitions and the partition size. To find out the size in gigabytes, we have to calculate it manually. In this example, we see 8 LPs, 16 PPs, and 2 copies. It means the mirroring. So the useful logical volume size is 8 multiply 128. It's 1 gigabyte. Logical volume placement at the volume group may be very chaotic. I've specially crafted this picture to show it to you. I've used different shapes for different logical volumes. Surely, when the system creates the logical volume, it tries to place it sequentially at the physical volumes. Chaotic placement may significantly impact the performance. Such chaotic placement may be the result of the changes you've made while creating, deleting, increasing, and decreasing the logical volumes. Any flexibility always brings some drawbacks. But don't worry, you may reorganize the volume group and move your logical volumes to make it sequential again. Online, without unmounting the file systems. Lsvg-m shows you the exact placement. We will look at this command one more time in this lesson. Here, we see the placement at the whole physical volume. Don't bother about the region. There are no any physical borders or logical borders, no any borders between regions. Forget it for simplicity. If you want, you may see the full detailed allocation map, partition by partition. I have used this command, I don't remember when I did it really. I show it to you now just because it helps to understand the LVM architecture. And for example, we see that there is the second copy of HD4 resides on this disk. As we see HD4, 1, 2, HD4, 2, 2. It means first logical partition of the HD4 and the second copy of it. Second logical partition, second copy of it. If there is a first copy, this number 1 will not show, like HD3, 1. It's first logical copy, first logical partition of HD3. Oh, some options to see where the logical volume mirrors. I will tell about mirrors in this lesson on next page. There is no way to show all logical volumes from all volume groups in one command. But there is a very useful option -i. It tells the command to get the parameters from the standard input. In this construction with the pipe, we see how to use it. It's very useful. Remember this option. It may be Lsvg -o pipe Lsvg -il and so on. Okay, let's look at the LVM possibilities and limitations. Logical volume can be expanded on the fly without unmounting the file system. The file system can grow with the logical volume. We see a volume of 5 partitions, and the volume is increased to 7 partitions. I especially drew a chaotic distribution of partitions. In reality, the operating system will try to place them sequentially, unless you explicitly order it to be done differently. Why am I showing such a strange placement? To re-emphasize that LVM converts physical disk space to logical one. From the logical point of view, your logical volume is always sequential. Moving a logical volume within a volume group. We moved the logical volume and now it's sequential. This is also done on the fly without stopping anything. Your applications are still working. LVM mirroring. software rate 1. I told several times that I will describe it, and now it's time. Let's take a closer look at it. We can mirror an already existing logical volume on the fly without stopping, as in this example. We can immediately create a new logical volume with a mirror from the start. Here we see a logical volume with 2 copies. It means that each one logical partition corresponds to 2 physical partitions. Sometimes it's confused and it's believed that 2 copies means the original plus 2 copies. This is not true. 2 copies are 2 physical copies of logical data. The number of copies cannot be 0. 1 copy means there is no mirroring. The first copy always exists. I promised to show the Lsvg-m command again. I keep my promise. We can see that the first copy of the data is located on HDisk 0. The second copy is on HDisk 1. A third copy can be made, but is rarely used. For example, to take a snapshot. Or in GLM, okay, on next lessons. LVM topic is really huge. Pay attention to the copy number. It's important. If you need to disassemble the mirror and remove the copy, then you need to indicate the copy number. If you are wrong, you may delete the wrong copy. You will have to create a copy again, synchronize the data again. You will waste time and impact the I/O performance. So, again, mirror copy number is important. How does mirroring works? When you write data, it's automatically written to all copies. When you read data, it reads from an accessible copy. I emphasize that it does not matter to LVM what logical structure lies on the logical volume. It can be a file system or paging space. It may be anything. There are several algorithms for selecting a copy to read from. I will go into more detail about them in the next AIXology tutorials. When all copies are available, the status of the volume is synced. When some of the copies are not available, stale partitions appear. I have to remember this. Synced stale. You've seen it already on this tutorial. Now remember that I said stale 0 is good. The entire logical volume is synced. Surely, if you're expanding a mirrored logical volume, then you do not need to further mirror it after all. It's already mirrored, and the expanded part will be automatically mirrored too. LVM limitations. I will not list all these numbers in detail. You can read them yourself. I will explain it shortly. LVM appeared in AIX about 30 years ago. There was only one type of volume group. It's now called standard. 30 years ago, its limits seems huge. 32 physical volumes, 1016 physical partitions of 1 GB per each physical volume. But the amount of data is constantly growing. Now such limits looks very small. Therefore, the big volume group type appeared with increased limits. and then the scalable volume group. They revised the internal architecture and were able to remove some of the restrictions. Things to remember. Root VG is created as standard VG. This is usually enough. The rest of the volume groups are usually more efficient to create as scalable. Standard VG may be converted to the scalable volume group. Forget about big volume groups. I see no sense to use them. Scalable volume groups are they are more scalable. By the way, why the standard VG limitation is 1016 partitions per volume? It's simple, because 1016 is 1024 minus 8. 1024 is magical number for any IT specialist, yes? Okay. 1024 minus 8. 8 physical partitions are spent to the LVM structures. Surely the LVM flexibility needs some resources to store its structures. They are stored on the same physical volumes. You will not see them directly using the high-level commands, but trust me, they are there. How to manage volume groups? How to create logical volumes? How to do anything? How to change something? I've described a lot of possibilities, but not showed any commands. Not this time. It's already quite a long session. It's spent already 40 minutes already. Surely, there are Smith menus where we can find the most of managing options. I have already explained how the Smith works at the AIXology lesson 1. There will be next AIXology lessons about the LVM management. Subscribe to our channel. If you want to try to learn it yourself, be careful and read the documentation first. Don't play with business data. Finally, let's take a quick look inside. LVM data structures. As I said already, they are located on the same physical volumes that are included in the volume group. They are copied into ODM and memory. Volume group descriptor area, VGDA, basic structure, contains information about the volume group and the volumes included in it. Each physical volume has 1 or 2 copies of the VGDA. Volume group status area, VGSA, contains information about the status of LVM mirror copies. Logical volume control block, LVCB, a description of a specific logical volume. Due to the fact that these zones are located directly on disks, you can take a volume group, physically switch it to another instance of AIX and extract all information about the group, volumes, and file systems from it. It's called export VG and import VG. LVM component identifiers, VGID, PVID, LVID. These are unique numbers that are used for low-level operations. As usual, the names of the components are for the humans. The numbers are for machine. The physical volume ID may be generated at the factory. If not, then the server serial number, timestamp, and random number are used. In this example, we see how the machine serial number was used to generate the identifiers. As a rule, you don't need to somehow manage this. Everything happens automatically. Finally, I repeat basic comments. As usually in AIX, ls for list, and then what I want to list. Physical volumes, volume groups, logical volumes. Option -L for logical placement, -P for physical placement. Option -I to get the list from the standard input. Use it with pipes. I insist on command line to list the LVM structures, not Smith. Why? While working with LVM, you will get that you need to see several attributes listed by several commands on one screen. Smith does not provide such functionality, so in this case, command line is more suitable. Command syntax is quite easy to learn. To list LVM structures, I recommend to use commands, not Smith, even if you are a newbie AIX system administrator. Frequently asked questions. Can I work with physical volume which is not included in the volume group? Yes and no. Yes, because you may use it, for example, for Oracle ASM. No, because from the LVM point of view, this volume is still empty. Do remember that the physical volume is the disk device at the background. When you work with raw physical volume, you really work with disk device, not the physical volume. Can I use the third-party LVM? Why not? No more comments, but someone tries. Can I move the logical volume between volume groups? Can I backup the whole volume group? Yes! Read the documentation, go to training courses, watch the next AIXology lessons. There is a lot of features in LVM. What we have learned. The Logical Volume Manager is a flexible storage management solution for the AIX operating system. Main components are volume group, VG, physical volume, PV, logical volume, LV, physical partition, PP, logical partition, LP. To work with LVM, both Smith and command line interface may be used. What can you do yourself? Using Smith or the command line, look at LVM structures and find the answers to these questions. System administrator rights are not required to run these commands, but I warn you that working on a real system is always a risk. I'm not responsible for any consequences. You make decisions yourself. This is the AIX Portal, independent community of IT professionals. We like to share information about AIX, IBM power systems, and anything extra. You may find us at our main website and in social networks. Our primary language is Russian, but be sure, if you ask a question in English, we will answer. The IT language is the same in the whole planet. I'm Dmitry Mironov. I will be glad to see your comments and questions. We will meet on the next AIXology lessons. Best regards. Bye-bye.